Hello everyone, today in this video we'll be discussing the third module of DSA. What are all the things you need to know from the third module, and if you watch this video till the end it is sufficient for you to score more than 80% marks, so don't miss any of these topics. And please do like and subscribe, it helps me make more videos like this. So without wasting more time, let's get started. The first question is, write a recursive C function for in-order, pre-order and post-order traversals of binary tree. Also find all the traversals for the given tree. So a tree is given to us, and firstly we have to write functions. Okay, we have to write recursive functions. Okay, there are two types of functions, iterative and recursive. The important one is recursive one, and we have to write the recursive function for in order, pre-order and post-order traversals, and after that we have to apply those algorithms to find out the in order, pre-order and post-order traversal for the given tree. Okay, that is for the 8-mark question. Let's get started. The first one is in order traversal. Okay, in order means what? LNR, you have to remember this. LNR means left node right. Okay, so traversal means what? Traveling to all the nodes. Okay, the way in which we travel to all the nodes, that is called as a traversal. There are three types are there. So first one is in order. In order means LNR. LNR means we'll first visit the left part. If the left part exists, for this also we'll visit the left part. If the left part does not visit, we will print the node and then we'll visit the right part. If right part does not exist, we'll come back and visit this part here. And for this part, the left part is over, so we'll print this node and move to the right part. Like that we'll keep on going. Okay, each node will be doing it in this way. That is called as in order traversal. So here is the function void in order and tree node pointer. If pointer is existing, then in order ptr left. Okay, this is all you have to write. In order, we'll call the same function again with the pointer as pointer arrow left, then print f pointer data, then in order ptr arrow right. So first we are going to the left and completing that one, then we are printing the data, and then we are going to the right. This is in the form lnr. Okay, left we are first going, then we are printing the data, which is nothing but node, and then we are going to the right. Okay, this is the in order traversal. Similarly, we have pre-order traversal. In this, node will be printed first, then left, then right. Okay, so the only difference you need to make here is first the printing operation will come here, then ptr left, then ptr right. Okay, and in the post order we have lrn. Post order means at the last we'll print the node, and before that lnr will happen. So left here and right here, and data will be printed here. These are the recursive functions for in order, pre-order and post-order traversal. Now for the given tree, okay, this is a tree which is given to us. I have written on this tree here. We have to write the pre-order, in order and post-order traversals for the given tree. So let's have a look. How do we do that? Okay, so see, first is a here, right? First is what? First is a here. So if we are applying nlr in pre-order, whatever is present here, that will be printed first. Okay, the node will be printed, then we will go to the left. When we'll go to the left, again nlr will be applied. If we apply nlr here, first b is there, so b will be printed. Again we move to the left, and in this part again nlr will be applied. So n will be printed here, so d will be printed. Okay, n will be executed, so d will be printed. Now then after n, l is there. L left part is there? No. Right part is there? No. So we'll go back. Okay, so nlr is completed. For d, we'll go back here. For the b, n was completed and l was also completed. R is remaining, so we'll go to the right. When you go to the right, again nlr will be applied here. For e, so on E, first E will be printed, then left and right will be checked. So left exists, so we'll go to the left part here, and NLR will be applied for H also. So H will be printed here. Okay, and L and R will be nothing here, so it will come back. When it comes back, N was over, L is also over, R is present. So it will go to the right. When it goes to the right, I is present, so I will be printed, and there is no left and right for I, it will go back. For E, N, L, R all are over, it will go back here. For B also, N, L, R all are over, it will go back here. And for A, N, L, L is over, R is remaining, so it will go to the right. And on C, N, L, R will be applied, so C will be printed here. After that, N is over for C, L is remaining, so it will go to the left. When it goes to the left, F is present, NLR will be applied on F, F will be printed, and it will come back here. And R is remaining, it will go to the right, and G will be printed, and again it will come back. NLR is over for C, and NLR is over for A. That's the pre-order we will get here. Okay, next one is in order. In order is L and R. Okay, so from A we will start. First we'll go to the left, again we'll go to the left, again we'll go to the left, nothing is there, so we'll come back here and we'll print it. First is L, N, R. So after L is N, so we have to print the node. So first we'll print D, then it will check the right, right is not there, it will come back. Left is over, L and R, left is over, N is present here, so B will be printed. R, it will go to the R. Here also first L and R will be applied, it will go to the left, again L and R will be applied. Here H will be printed, L and R is not there, so it will come back here, L is over, N is there, N means E will be again printed. Okay, and after that it will go to the right again, and L and R will be applied on I will be printed, come back to E, L and R is over, it will come back to B, L and R is over, it will come back to A, L part is over, N it will print A and it will go to the right. When it goes to the right, L and R will be applied on C, again it will go to the in F also L and R will be applied. When it will be applied, F will be printed, it will come back here on C, L N C should be printed. Then again it will go to the right, it will print G, which is the L and R, and when it will come back, C will be over with L and R and A will also be over with L and R. Okay, so in order will be this one. Okay, next is post order. In post order, first L R N. Okay, first left and right both should be over, at last we will be printing N. Okay, so on A, L R N will be applied, B L R N will be applied, D L R N will be applied, so D will be printed. Left, right is not there, so D will print. Then we'll come back to B, left part is over, it will go to the right. L R N again, L R N again. On H, L R N will be applied and H will be printed. It will come back and E will check, L is over, R is remaining, so it will go to the right of E, which is I, so I will be printed. After that, L R N will be applied and nothing is present, and it will come back here, L and R is over, so E will be printed. Okay, L R N, right, so E will be printed. Again it will go back, left and right of B is over, so B will be printed after that, and it will come back and it will check with A, L is over but R is not over, so it will go to the right. On C, L R N will be applied, on F, L R N will be applied, F will be printed, it will come back on C, L is over for C and R is remaining, so it will go to the right. G will be printed, L R N is done for G, L R N is done for C, and L R N is done for A also. So all the elements which are printed at the last, A will be printed. Okay, L R left and right was over for A, so after that N is there, so A will be printed. And before that, before printing A, C will be also printed. Okay, C, L R was over for C, N means C should be printed. After that, L R was over for A, so N means A should be printed. Okay, so this is the pre-order, in order, and post order traversals for the given tree. Okay, moving on to the next super important question, which is define a binary tree and explain the array and linked representation of binary tree. So there are two types of representation. First, we will define what is a binary tree. Okay, what is binary? Binary means two. Okay, binary means two. So I explain the array and linked representation. Two types of representation are there. This is for 8-mark question. Okay, so a tree which can have at most two child nodes. At most means it can be either 0 or 1 or 2, but it cannot be 3. Okay, that is called as at most. At most two child nodes is called as a binary tree. Okay, so a tree which can have at most two childs, it can have one child also, it can have 0 child also. All these are binary trees. And the two representations are array and linked representation. First, let's understand what is array representation. So in array representation, if a complete binary tree with n nodes is represented sequentially, okay, sequentially means one after the other. If we are representing it in this form like an array, we will be calling that as array representation. Okay, and the index will be from 1 to n. Okay, so we have three conditions here. Parent of I is at I by 2. Okay, and left child is at 2i, and right child is at 2i plus 1. Okay, you need not understand these rules, just write something similar to these rules. Okay, but the main thing is the representation here with the example. So the example, you can make it like this: A, it has two childs B and C, B has two childs D and E, C has the left child F, and D has the right child I. Now when you make this level here, what happens at level 1? Firstly, always you will be making a null here at the root node. Okay, and from here you will be writing then A, B, C, D, E, F. Two things are missing here. Why it's missing? See, actually the thing is, A is here, so A is written. Okay, and A has two childs B and C, so B and C is written. Then B has two childs D and E, so D and E is written. C has only one child F and another child is missing here. Okay, so wherever it is missing, we'll put is empty, so it will become F and empty. Okay, F and empty. Then again coming here, first child is missing here, so it will be empty and I. Okay, empty and I, it will be like this. Will represent using array. If you want to represent using linked list representation, the struct node will be defined here with data and node star left and node star right, and type def struct node tree node. Okay, after that the data will be present here and the left part will be in the left and right part will be in the right. Okay, this is the representation. For an example, you can take this into consideration. A has two childs B and C, so B and C will be connected with the pointers present here, and B has two childs D and E, so again B will be having D and E here, and since A has only right child, only the right child will be present here. I mean, A has the child which does not have any other child, right? So C will be present here without any more further expansions, and D and E also the leaf nodes. So at the end, it will be just pointers. If suppose E had another child here, like K, so in that case, E's right child will be pointing to K here, like this. Okay, like this, and this will be null. This will be null. So in that way, we'll be writing the representation. This is called as linked representation. Okay, very important question from exam point of view. Next is define threaded binary tree, construct in threaded binary tree for the following. Okay, so a sequence of letters are given to us, and first we have to define what is threaded binary tree, and then we have to construct the in threaded binary tree for the given sequence. Okay, so we also have to write the functions for the in threaded binary tree, the successor function and the traversal function. Okay, I'll be discussing that. This is for 8 marks question. Okay, so firstly, what is threaded binary tree? A binary tree, okay, a binary tree that has more null links than pointers. Okay, it has more null links. Okay, null links means what? In the previous question I discussed, this is null link, this is null link, which does not have any further children, that is called as a null link. It has more null links than the pointers. These null links can be replaced with special pointers called as threads. So instead of keeping this as null, we will be replacing them with some threads. Okay, that is called as threaded binary tree. Okay, so now in threaded binary tree is a variation of binary tree in which in order traversal is more efficient. Okay, here the in order traversal will be taken into consideration. Okay, so the in threaded binary tree for A B C D E F G H I is, firstly we will make normally. Okay, A, then we'll make two divisions here, B and C. Again we'll make two divisions for B, D and E, and two divisions for C, F and G, and for the D again two divisions H and I. In the same order we'll be going, first this, next, 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 like that. Okay, so this is the tree made. Now for you have to make the threads also. How will be the threads made? Okay, observe carefully which node does not have two child. Okay, my question is very clear. Which node does not have two child? Okay, which among the whole tree nodes does not have two child? Does A have two child? Yes, A has two child. No, will not consider A. B has two child? Yes, B has two child. Will not consider B. C has two child? Yes, C has two child. Will not consider C. D has two child? Yes, D has two child. Will not consider D. But E, F, G, H, and I does not have two child. Okay, so in that case, since it does not have two childs, or it does not have any child. Okay, so in this case, we'll get two links here. One for the right, one for the left. One for the left, one for the right, one for the left, one for the right. So wherever children is not present in a node, that we'll be taking as a thread. Okay, let's start from H. In the left part of H, what you can see directly, you can go to A here. So our link will be made from H to A because it's the edge node here. If we go like this, first what will come? A will come. So we'll put a thread to A here. Okay, next H left part is done. In H right part, if you go first, D is coming, right? So we'll put this as D here. Next I. If you go to the left of I, first D is coming. If you go to the right of I, B is coming. E's left part B is coming, E's right part A is coming, F's left part A is coming, F's right part C is coming, G's left part C is coming, G's right part A is coming. So like that we'll make the threads. Okay, by using these threads we can easily access the next nodes. Okay, so why it is faster is, firstly if you go like this, like this, like this, instead of again going back in the same way, we can directly go to A from here, right? So that's way it will, that's how it will save time. Okay, the structure of it is as follows. We'll have struct node, and for the left part we'll have left thread, left child, and for the data we'll have in middle, and for the right thread we'll have right thread and right child here. Okay, and we'll write type def struct node thread node. Okay, this is a structure for the thread node. Next, the following is a visual representation of the node. The data part will be present here. This is the left child and left thread, and this is the right child and right thread. Okay. Now you have to write the functions for it. Okay. In order traversal for a threaded binary tree. Okay. So in order successor we have to find. Okay. I was telling, right, if you go like this, where it will come. If you go like this, where it will come. That is called as in order successor. Okay. For that you have to write the function. Thread node is the return type. Thread node star. In successor is the function name. Thread node star tree. So we will accept a pointer here as tree. We'll create a temporary pointer here, and that temporary pointer will be pointed to tree arrow right. So right subtree of that will be temp. Temp will be starting from the right subtree. Now if tree arrow right is equal to F, means tree's right part. Okay, If tree's right part is f, means there is nothing present in the right part. Then we will apply a while loop. While temp arrow left thread is equal to f, while the left part is also null, at that case we'll go to the left till that point, and then we will return temp. So basically what we are doing, firstly we are considering the right subtree, and from there the leftmost part we are considering, that is the in order successor for the given node. Okay, so this is the code you have to write for in order successor. Next is in order traversal for the threaded binary tree. Again we'll take it as like this, in infinite loop here. Thread node start temp is equal to tree, we'll start from here and we'll find out the in successor of temp. And once in successor of temp is found, if it is equal to tree only, means only one node is present, we'll print that node and we'll break it. Else what we will do, we'll keep on going and we'll be printing the temp arrow data. Okay, temp arrow data means the temp's data will be printed. After that again tree will come here, and in order successor for that temp will be found and stored in temp. Next successor we will print here, and again we'll print the next successor, and so on. Okay, that is the in order traversal for threaded binary tree. Okay, moving on to the fourth super important question, we have defined the following terminologies in a tree. Okay, firstly, what is a tree? They can ask you the definition of the tree also. This question is for 8 marks, 6 marks here. Okay, in case they ask you for the definition of tree, it can be even for 8 marks. Okay, so the definition of a tree is a finite set of one or more nodes. What it is? It is a set of finite set of one or more nodes. These are the nodes. A set of it is called as what? It's called as a tree. So a special node is called as a root, and the remaining nodes are distributed in many groups, such as called as subtrees of the root. Means the left part of the root and the right part of the root is called as subtree. Okay, so this is what the tree's definition is. Next, we have to define the following terms: degree, non-terminal, sibling, level, height, and ancestor. So this is the tree which is given to us. So let's consider this tree. Level is nothing but how many levels are there. This is first level, second level, third level, and fourth level. How many nodes are there to reach the last node? Okay, in between how many nodes are there to reach the last node? Okay, that is called as a level. So what is a degree? First they had asked degree. So what is a degree? The number of subtrees of a node is called as a degree of a node. So the degree of A is 3 because 3 subtrees are there, and degree of B is 2, degree of E is 0, degree of C is 1, degree of J is 3, like that. Okay, how many subtrees are there? That is the degree of a node, and the degree of a tree is maximum degree of the nodes present in this whole tree. What is the maximum degree you can find? That is the degree of the whole tree. Okay, and left or terminal nodes. Okay, so this is not left, this is leaf. Okay, leaf node or the terminal node is the one which has degree 0. Degree 0 means it does not have any more child. That is the leaf node. Okay, leaf node are called as terminal node, and the ones which are not leaves are called non-terminal nodes, which has at least one child. This is a non-terminal, 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 and so on. These are all non-terminals. The remaining ones, these are all terminals here in a box. These are all terminals. Next is siblings, children of the same nodes. Okay, siblings, like a normal family tree we can understand. These two children are there, E and F. So E and F are what? Siblings. Okay. Next is ancestor, all the nodes from the root to that point. Okay, means if we have one node here till the A here, all are ancestors. So E's ancestors are B and A, I's ancestors are G, C, and A, K's ancestors are J, D, and A. Okay, and the level is nothing but height of the tree. How many maximum nodes are there to reach the last node? Okay, that is the height or the depth, and level is also same, indicates the height of the tree. Okay, height is nothing but maximum. Height can be also called as depth. Okay, these are the definitions you need to write with the above example. Moving on to the fifth super important question, we have draw a binary tree and find out the binary tree traversals for the expression. So one expression is given. Firstly, we have to find out, means we have to draw a binary tree for it, and then we have to traverse it using in-order, preorder, and post-order traversal. This question can also be asked as expression tree. Okay, they can explicitly ask as write the expression tree, draw the expression tree for the following expression. Okay, and it is for 6 marks. Now, for expression tree, one thing you need to understand is the following the precedence rule. So this is the precedence rule. Okay, the opening braces and the closing braces will have the highest precedence. After that, the dollar operator, which is nothing for the power, means $2 is equal to 4, or I can say $3 2 is equal to 9. Okay, square values, square, cube, those values. Okay, this operator is nothing but a dollar operator. This is the multiplication, this is the division, this is the modulus operator, this is the plus, this is the minus. Okay, in this precedence you have to follow some rules. Okay, for the expression tree. Now this you have to by heart. Okay, the opening closing braces, the dollar, and star, slash, and modulus, plus and minus. Okay, this is the decreasing, so this is the least precedence and this is the highest precedence. Now the lower precedence, okay, the lower precedence will be selected. Always lower precedence which is there in the equation, that will be selected for the root node. Okay, now let's take an example here. Suppose that this is the equation given to you, okay, and you have to draw a tree, expression tree for this one. Your first step is to find out the least precedence operator. In this, how many operators are there? Plus is there, multiplication is there, and division is there. The least among plus, multiplication and division is what? Plus, right? Plus is the least precedence one. If you see this precedency format here, the order of precedency, the decreasing order is in this way, so the plus is in the most rightmost part, means the least one, so plus will be considered. Plus will be considered, and left side of f left side of plus will be a, and right side of plus will be this following. So left side I will make it as a here, and right side I have to further do something. Okay, again I'll consider multiplication or division, which is having the least priority. Least precedence is division, so I'll take division as the root node, and I'll separate it. In the right part it will have D, and the left part it will have B star C. So star will be in the middle and B and C will be here. Okay, this is how we have to follow the precedency rule to generate the expression tree. Okay, now for the given expression which they had given, you have to construct the binary tree as follows. Okay, now in this whole equation which is having the least priority or the least precedence is plus here and plus here. Minus is also there, that's the least one. If you actually have a look at here, the minus is present at the last, so minus should be considered, right? But minus is not independent, it is under this one. So when something is under this one, this will be taken as one separate entity, and this will be the one which is taken into consideration, and this has highest priority here, so this one will be ignored. Okay, whatever is inside this will be ignored if it is under the braces. Now here plus is there which is open. Okay, you have to check. In case if it was 6 plus 8, inside this we will be considering minus. Okay, when we individually consider inside this what to make, but outside this, when this comes, we have to take this as highest priority, and the least priority here is plus and plus here. Two plus are there, any plus you can take, both are same only. Okay, so I'll take this plus here, and the left part I'll make it as 3, and the right part will be this whole equation. Again, in this whole equation, which is the least priority? The least priority is this plus here. Again I'll take as plus here, and the right part is 3, so I'll make it as 3, and left part is all of this until 4. So all of this until 4 in this part, which is the least priority? Minus I mean the multiplication or the division or the parenthesis, which is the least priority? Division is the least priority, right? So division will be taking it here, and the right part of division is 4 here, and the left part is this following equation. Now in this multiplication or parenthesis, which is having the least priority? Least priority is multiplication, we will make multiplication here, and the left part of multiplication is 4, so we'll take 4 into consideration here. After that, this is the thing which is remaining. Now we will come inside this. When you come inside this, only we have one operator minus, so we'll be writing here as minus, and the right and the left part will be segregated and written as 7 and 6. Okay, so this is the expression tree which you need to form. Okay, this is the expression tree. Okay, after that they have also asked in the question that we have to find out the traversals. Okay, binary tree traversals for the following. Okay, but find out the binary tree traversals for the following. Now let's find out the binary tree traversal using the same equations which we had done previously also, NLR, LRN, and NLR. Okay, now see, the plus is present here. Okay, NLR, we have to always do the same order here. NLR, so N means plus, plus will be printed here, and then L. After that, it will go to the left, and 3 will be printed here, and right is not this, so it will come back here, and it will go to the right part here. In the right part also NLR will happen, so first plus will be printed, and then left it will go, NLR will happen, division will be printed, it will go to the left, multiplication will be printed, it will go to the left, 4 will be printed, and LNR will happen, and it will come back here, and N is over, and L is also over, and R it will go here. NLR will happen, minus will be printed, it will come into this part, 7 will be printed, and it will come here, 6 will be printed. Okay, and after that it will go here, NLR is done. Again it will go here, NLR, N is done, L is done, and R it will come and print 4 here. NLR is done for this also, N and L is done. R it will go and print 3 here. Okay, then it will come back, NLR is done, here also NLR is done. So this is the pre-order traversal. For the in-order traversal, we have to do L and R. First we'll go to the left, and then we'll print 3 here, and then we'll come back, and we'll print as plus here. L and R applying on this, left part is over, so in N plus will be printed, it will come to the right. again LNR will be applied, left LNR, left LNR, left LNR. So first 4 will be printed, then it will come back here, L is over, so N will be printed as star here, and it will go to the right. Again LNR will be applied, it will go to the 7. After that it will come back, LNR will be applied, so minus will be printed here, then it will go to the 6, 6 will be printed here, then it will come back, and back when it comes back to star, L and R all are done, so it will come back here, L is done, N is done, N is not done, right? So N will print division here. Okay, after that it is 4, it will go to the right, and it will do LNR and print 4 here. Then it will come back to division, LNR is done, it will come back to plus, L is done, but N will be printing plus here, and it will come back to 3, LNR will be applied, 3 will be printed, it will go back, LNR is done, it will go back, LNR is also done, right? LNR, yeah, LNR is done here. So this is the in order traversal. Next is post order traversal. For that, LRN, first left and right both will check, at last we will print. Okay, so first it will come here, LRN, it will go here, LRN, 3 will be printed here, then it will come back here, and it will go to the LRN, again left, 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 4 will be printed, LRN is done, again star, again LRN will be applied, here also LRN will be applied, and here 7 will be printed. When LRN is done for 7, it will come to minus, L is done, right it will go, and it will print 6, and it will come back, L and R is done, so N will print minus here, and it will come back, L and R is done for star, N will means star will be printed, and star will be printed, it will come back here, and LRN, right? So L is done, R it will go and print 4, and it will come back, and LRN, N means it will print division, and again it will come back here, plus is there, L and R, L is done but R is not done, so it will come back and come and print 3 from here. It will go back, LRN is there, right? So left and right is over for plus, now N will print the plus value here, and after that it will go back here, and L and R both are done for the first plus root node, L and R is done, so the N means the last plus will be printed here. Okay, so this is the post order traversal. Okay, so these are the different types of traversals you have to make for the expression tree. Okay, moving on to the sixth super important question, we have defined a sparse matrix. For the given sparse matrix, do write the linked representation. Okay, so firstly, what is a sparse matrix? Okay, don't get scared by this one. I'll make it in a simplified manner for you. So what is a sparse matrix? A matrix in which majority of elements are zero. Okay, this is the key point you need to write. What is the key point? What in the sparse matrix, the majority elements are what? It is zero. Okay, means more zeros are there than other numbers. That is called as sparse matrix. So the linked representation next you have to make the for the given array. So follow the steps which I tell you. Okay, the first step is how many columns are there. You answer me, how many columns are there? 1 2 3 4 5. 5 columns are there. How many rows are there? Rows are 1 2 3 4. 4 rows are there. Just keep this in mind. 5 rows and 4 columns are there. And how many non-zero elements are there? One non-zero element, second, third, fourth, fifth, sixth. 6 non-zero elements are there. Okay, non-zero elements are how many? 6 are there. Okay, so how many is the column? Column is 5, and the rows is equal to 4, and non-zero elements is equal to 6. 5 4 6, right? So that same thing you'll be doing here also. Firstly, make this one. Okay, first forget everything what is whatever you can see in the screen, forget everything, start from here. First make this box here. Okay, in this box you have to make 3 divisions on the top. Okay, and 2 divisions on the bottom. Okay, after that in the first division you'll write how many rows are there. 4 rows are there. Second you'll write how many columns are there. 5 columns are there. And here you'll write how many non-zero elements are there. 6 non-zero elements are there. Okay, after that the 4 rows are present here, right? So you'll make 4 boxes like this. Okay, a box like this and like this. Okay, like this, like this, like that. You'll make 4 boxes here for the first row, second row, third row, and fourth row. Okay, and how many columns are there? Columns are 5, so 5 columns you'll make here, 5 boxes. Okay, forget everything about the arrows. I'll tell you what the arrows are, but focus on this. First you'll make 4 boxes here for the rows, and 5 boxes here for the columns. After you have done this one, there are 6 non-zero elements. Okay, just keep it as such. Next, what you have to do, this is for making the connection in the row direction. Okay, this is for the row direction. Okay, this one is for the row. This is the thing you need to remember. This column, the left column is for the left cell is for the column, and right cell is for making the connection with the rows. Okay, column, row, in that way. Okay, so since this is row, we will be making it like this, and from here we will not do anything. The above will make the connection like this, like this, like this. We'll keep on making the connection, and the last one will be again connected back to the first one. Okay, this is the way you need to do for the first top row, and for this one you'll just make it and keep it as such. After you have done that, you have to start making the cell values. Okay, first cell value is 3. So how do you make the cell values? See, the 3 is one value here, right? So how do you make the value for 3? Now 3 is coming in which place? The 0th row and 0 1 2 second index. So 0 comma 2 is the place where 3 is coming, right? So again you will make a box here in the 0th row and the third column. Okay, 0 1 2 and 0th row. You'll make a box here. Okay, just make a box similar to the box you have made at the top, and you'll make 2 divisions at the bottom and 3 divisions at the top. Okay, and what you will fill here? You will fill here which row it is. It is a 0th row, right? And which column it is? It is the second column, means the index column of number 2, right? 0 1 2. So you'll write 2 here. And what is the value of the non-zero element? That is 3. This is a 3, which is the value of the non-zero element. After you have done this much, leave it as such. Forget about the arrows. Okay, you have done this one. Next is which non-zero element? Next non-zero element is 4. So the 4 comes at the last year in the index number as 3 in the index number 4 in the column, and index number 0 in the row. So 0 in row and fourth index of the column. Okay, so 0 4 will be written here, and the value of non-zero element is 4 here. So you'll write it as such. Okay, then you do it for all the other ones also. So below 3 5 is coming, and beside 5 7 is coming. So below 3 5 is coming, so it is a row number 1 and column number 2, and the non-zero element is 5. And this is row number 1 and column number 3, and the element is 7 here. Like that for the remaining one also. At the last row we have the row number 3 and column number 1 with the non-zero element 2, row number 3, column number 2, and non-zero element 6. Okay, the below 2 1. After you have done this much, how do you make the arrows? Remember this one. The arrows you have to fill in two parts. First you will fill the columns, then we will fill the rows. How do you fill the columns? See, if you observe here, there is no column present. Okay, start from here. Okay, to fill the columns, you'll start from each column and fill it. Okay, now in this column you can see there is no other element present in this column, so this will be pointing to self. Okay, next for this column, there is one element, so we'll point to that element, and that element's value from here you will be pointing to here. Okay, and for here first you'll point it to this one, and from here it will be pointed to this one, from here it will be pointed to this one, and from here it will be pointed to the, okay, and from here also the same thing, it will come here and it will go here. Okay, and here also it will come and go here. So the column part is over. Next is what? Next is row part. For the row part, what you will do? For the row part, start with this row. When you will go like this in this row, you will encounter this element. From here again you will make an arrow, encounter this element, and from here again you will make action. Again for this, whichever elements you encounter, do it and come back. If there is no encountering of the elements, make it as a self pointer, and wherever it is having the elements, go pass through the element, come back to the same row here. Okay, this is how you do the linked list representation for the given sparse matrix. Okay, moving on to the seventh super important question, which is define doubly linked list. Okay, write the functions to perform the following operations on a doubly linked list. See, they can ask you the question related to singly linked list also. For the same values, you can be asked singly linked list also, circular linked list also you can ask, or they can ask you circular doubly linked list also. All those questions have been appeared. Okay, so I've just taken doubly linked list as an example. If you understand the concept which I'm trying to tell here, how you will be able to write the functions, any type of question which will be asked here for any of the ones, like doubly linked list, singly linked list, circular linked list. For all these three you can write the functions if you listen to me carefully. Okay, I'll teach you how to actually write the functions, or from your own. Okay, no need to by heart any of these functions. There are many functions. Okay, you should not by heart, you should understand the concept. Okay, and this is for 12 marks, 3 marks for each of these questions. Okay, so don't miss at any cost. Now see, what is a doubly linked list? First they've asked define doubly linked list. Okay, this also a mistake students can make, that you will forget to define this one. Okay, you'll just start writing the function, so some marks you will miss. Okay, that is not needed. So you can easily write the definition of this one. What is a doubly linked list? It is a linked list which has two link parts. Okay, double means what? Two. So two links parts are there, left link and the right link. Okay, that's what. And then you have to write the structure of the node. Okay, this is a node here, and here you will have node star l link, and the data will be present and the right link will be present, typed as struct node d node. Okay, so this is the structure for the node of the doubly linked list. Now the code part. Okay, the code part, inserting the node at the rear end of the list. So the first question they had asked is inserting the node at the rear end of the list. Okay, rear means the last part. Okay, if there is a like this, it is a linked list is present here, you have to insert it at the last part. Since these are doubly linked, there will be double arrows here. Okay, at the last part you have to insert a node. So the way to write the code is, firstly you will be writing d node star, which is the return type. So we have defined d node here. So d node star, insert it at the end. Okay, and the head value is given to us and data is given to us. Head is nothing but the first node. Okay, and here a function is called d node star new node create node and data. This create node, another function is there. I have not given the definition of the function, but it actually does the same thing. Node star new node is equal to node star malloc size of new node, and it will become, initially it will be null. Data node star arrow data is equal to null. Node arrow l link is equal to node arrow r link is equal to null. We are just initializing a node. Okay, initialization of a node, that's a very simple code you can write by your own itself. Okay, just have to put the data part and left and right link as null. Okay, if you watch the previous module video for the linked lists, I have explained there how do you write the starting part of the node. Okay, for the single linked list. So after that, you'll be initializing head as null. Okay, head is equal to null. If head is null, we are checking, then we'll be returning a new node. Head is null means the list is empty, so a new node which you create, that only will be returned. So only the this node will be present in the list. If that's not the case, means it has more nodes. You have to first reach the end of the node. To reach the end of the node, we will create a temporary node here pointed as head. Temp arrow r link is not equal to null. Till this condition gets true, we will keep on moving. Temp is equal to temp arrow r link, so it will go to the right, next again right, until and unless the right link is null. When will be the right link null? When it is the last node. Last node means right link will be null. So we'll reach the last node, and after that, in the link part of the last node, we'll add the new node. Okay, we have reached the last node, and the link part of the last node will be pointed to the new node, so that new node will be added to the end of the list. Also, new node's l link will be equal to temp. Also, this is a doubly linked list. We have to also fill the left part of the node. This is a new node. This left part will be pointed to the second last element, which is pointed by temp. Okay, so this is inserting at the end. Deleting node at the rear end of the list. Okay, how do you delete at the rear end of the list? Means the last node you have to delete. So the logic for it is as follows. To delete a node at the end of the list, first you will check if the list is empty or not. That's what we will check. If head is null, means list is empty. If it is not null, what we have to do, we will have to check if there is only one node or not. If there is only one node, means we will just delete this same node. We need not do anything. So for that, head arrow r link is equal to null, we will check. If it is null, free head and return null. Okay, this is for one node. If it is having more than one node, means you have to first travel till the end of the node. How do we do that? Again, we will create a temporary pointer here, and temp arrow r link is not equal to null. We will go to the right, temp is equal to temp arrow r link. Once we have reached the end part, what we will do, we have reached the end part, and this node has to be deleted. But before deleting this node, the right part of this node has to be made as null. We are currently present here, and the right part of this has to be made as null. So for that, what we will do, temp, which is the current node we are there, temps l link. What does temps l link do? Okay, this part, what does it point? Temps l link means this is temp, and the left part of temp is pointing to the previous node. So temps l link will render as this node here, and this node's r link we have to make as null. So temps l links r link is equal to null. That means the second last node's next link will become as null, and we are present at temp only, and this temp also we will free, so that temp will be deleted, as well as the last part's null link part has also been made as null. So this is how we will be deleting the last node from the rear end, and we will be returning head. Okay, any type of question comes, first imagine what is to be done, note it down, and for that, what are the codes required? The codes will be like this only. First, you will traverse if it is to the last. If it is to the first, you will not traverse. You will just make some changes into the links. Okay, if you think it carefully, you will be able to actually write the code from your own. Okay, try it. And if you still don't understand, watch the previous module 2 video. There I have explained all the kind of possibilities for the linked list, for the beginning and ending, for the deletion as well as for the insertion. Okay. So moving on, searching for the element, the third question that asked, displaying the elements. So int search the element, and head is present here. This is the starting part, and key is the one where we have to search. Okay, key is nothing but our node is present here, right? And there will be left a link part and the right link part, and what is in the present in the middle is the data. That data every node will have, and which node has that key data, that we will have to find. Okay, means among all the data, which data has the value which is provided by the key. Okay, so we'll create a temporary pointer head here, and position will be 1 here. While temp is not equal to null, we'll always check if temp arrow data is key. If it is equal to key, we'll return the position. If it is not equal to key, we will go for the next node and we'll do position plus plus. So what does position return? Position returns which node among all the nodes is the one which has the data. Okay, if there is no data present, eventually it will return -1. Okay, that was about the doubly linked list and its functions. Moving on to the last super important question of this module, we have write a C function for concatenating two singly linked lists. It's for the 4 marks. Okay. Usually it comes for in between some other like 2 or 3 functions you have to write. In between, the most repeated one was concatenation. Okay. If you learn this, among this you can expect like searching for an element or inserting an element at the rear end or the beginning or the deletion of an element. Like that, 3 or 4 questions will be there. In a sub question, concatenation will also be there. Okay. That is the most repeated one. So concatenating two singly linked lists. How do we do that? So node star is the return type and concatenation is the function name. Struct node star list 1, this will be giving us the first list. Struct node star list 2 will give us the second list. Now list 1 is pointing to the first node of the list 1 and list 2 is pointing to the first node of the list 2. Now we'll create a temporary node here. Concatenation means what? We are joining it. Okay, this is the list 1, this is the list 2. Joining it means we are making a connection with this node to this node. Okay, understand the logic. You can write this function from your own also. To make a connection from here to here, what all I need? Firstly, I'll start from here. I'll go to the next node until I reach the end here. And this end part, link part will be nothing but it will be pointed to the list 2 so that a connection will be made. That's all what we have to do. Okay. Before that, few things we have to check. First is if list 1 is null. If this is equal to null means just return list 2. Okay. Concatenation of nothing with list 2 is list 2 only. If list 2 is null, in that case, list 1 concatenation with nothing is list 1 only. So I'll return list 1. Okay. And if that's not both the cases, means some elements are there in both list 1 and list 2, what we'll do is we'll take temporary as list 1. Okay, we'll point temp to here. Next, while temp arrow link is not equal to null, while the link part of temp is not null, we'll keep on moving. Temp is equal to temp arrow link, temp is equal to temp arrow link, and we will reach a point where it is null. In that link part where it is null, we have to attach list 2, right? So what we'll do, we'll do temp arrow link is equal to list 2. So the link part of the temp is connected with the list 2 here. So the link is made. Then this whole list will be considered as a single list and return will be done from the starting point of that. So the return will be list 1. So list 1 will be here and that will be considered as a single linked list. Okay, single linked list. That is a concatenation of two single linked list. Okay, so that's all for this video and please like and subscribe. It helps me make more videos like this. Don't miss any of these questions and thank you so much for watching. I'll see you in the next one.